Hello student, welcome to our fifth lesson. Here we are going to look at effect of heat on substances. We are going to start with state of matter. Matter is anything that has mass and occupies space. Matter exists in four physical states, namely solid, liquid, gas, and plasma that we discussed in topic 1, form 1. A substance can exist in any four states depending on the prevailing temperature. We shall discuss the three states of matter, that is solid, liquid, and gas, heating and cooling curve. When naphthalene is heated, its temperature rises steadily until it starts to melt. At this point, the temperature remains constant until all the naphthalene has melted, then the temperature starts rising again. Why do we see that? Heating in water bath does not allow the boiling point of naphthalene, which boils at a temperature of 218 degrees Celsius, and therefore, if you're using water bath, this temperature is not achieved or attained, and therefore protects the thermometer from breaking. Graph of temperature against time when naphthalene is heated to melting is called heating curve. If liquid naphthalene is allowed to solidify by cooling, a cooling curve is obtained. Here is the experiment setup. We have the thermometer, we have the clamp, standard clamp, we have naphthalene pieces inside there, we have water bath, we have wire gauge and tripod stand, and this is a source of heat. Note, if a thermometer of 0 to 360 degrees Celsius range is used in the experiment, naphthalene can be heated directly. We don't need to have the water bath. But since we have a thermometer which ranges between 0 to 100 degrees Celsius, hence use of water bath to protect this thermometer from breaking. Naphthalene melts at a temperature of 80.2 degrees Celsius and boils at temperature of 218 degrees Celsius. With a water bath, the boiling temperature cannot be achieved or reached, and that protects now the thermometer from breaking. Here we have the heating curve. We have heating from this temperature, room temperature. You heat up to this one, this is a melting point, then goes to the boiling temperature. Then we have the cooling curve. It is cooling from any temperature above there, then it solidifies here and then moves down to cool down to the room temperature. Regions in the cooling and heating curve. We have now, this is a curve. We have the solid room temperature. So we have different region A, B. Region AB, naphthalene absorbs heat energy at the temperature increases steadily. So the temperature increases. The heat absorbed increasing the kinetic energy. It increases the kinetic energy of the particle and they vibrate more vigorously. So the moving energy is increased at this level. Then at point B to C, there is no temperature change. Pure naphthalene changes its state from solid to liquid. It melts. The temperature remains constant at 80.2 degrees Celsius until naphthalene melts. So in this region, the heat supplied to the naphthalene is used to weaken the forces of attraction holding the particles of naphthalene together. The particles move far apart as the forces weaken, resulting to a change of state, i.e. from solid state to liquid state. That is why there is no increase in temperature. The heat absorbed does not cause temperature rise. Then we have the other region, C to D. This region, temperature rises steadily as liquid naphthalene absorbs more heat energy. The heat increases further the kinetic energy, causing the particle to move fast. so liquid to move fast. Then this stage is where now the state changes from liquid to gas. This is a boiling point in case you reach those temperatures. Heating of water or pure substance. When water is heated, H2O, temperature increases steadily as molecules absorb heat energy, which increases their kinetic energy. The temperature continues to rise until the water starts to boil. So here is the setup. We have the thermometer there, we have the distilled water, the boiling tube, we have the glass tubing, then we have the stand here. You supply heat. Evaporation occurs only at the surface of the liquid and at any temperature. So it is good to note evaporation occurs at the surface of the water or maybe the liquid, and it occurs at any temperature. Then boiling occurs throughout the liquid. It occurs throughout the liquid, boiling at a specified or specific or fixed temperature. Maybe in water, the sea level, it's 100 degrees Celsius. But for evaporation, any temperature and only at the surface, while boiling occurs at a fixed temperature. The glass tubing ensures that there is no pressure buildup in the boiling tube. So this one is to allow the air or maybe the vapor to escape so that there is no pressure buildup. Temperature of the remains constant as water boils. This is because heat energy supplied is used to break the forces attracting or holding the water particles together. So when the forces is being broken down, then the temperature rise is not experienced. As a result, some particles break free and water changes from liquid to gaseous state. The graph of temperature against time is plotted when water is heated to boiling. So here we have a very sharp boiling point. That is why it is horizontal, 100 degrees Celsius. This is time in minutes, and this is pure water. You note by when this part is flat or it is horizontal. Heating and cooling of pure substance. Change of state from solid to liquid and liquid to gas can be resolved by cooling. On cooling, gas condenses into liquid, and finally liquid freezes into solid. Some substances such as iodine do not undergo the above changes because they sublime. So iodine, we have iodine crystal, which when heated it changes directly to gaseous state without passing the liquid state. And when cooling, what we call deposition, it cools to form the iodine crystals. So deposition does not go through the liquid state. The explanation of the behavior of matter in terms of movement of particle is provided by the kinetic theory of matter. Here is the assignment on effect of heat on substances. There are 6 questions. Work them out and wish you success.